Hello everyone, I'm Pasindu Tennage. Starting with this video, I'm going to do a series of lectures on consensus protocols. This lecture series will be interesting to many people interested in systems, students, grad students, engineers, and other professionals. This lecture series spans several videos, and in each video, I'm going to focus on a key subtopic. In this lecture, we will first look at the traditional single database approach and the single point of failure problem. We will then talk about the notion of consistency and why we need a consensus protocol to ensure strong consistency. Then I'll introduce how consensus helps to achieve strong consistency, followed by some discussion on state machine replication. Before we dive into consensus, let's have a look at how traditional databases work. In a usual setup, there is a front end, a back end, and a database, and the database saves the content permanently. For simplicity, let us assume that the database maintains a key value store. Now, in this kind of deployments, the front end server receives requests and it sends them to the back end, and the backend processes the commands by interacting with the database and send back a response back to the client. Now, what's the problem with this approach? What if the single database crashes? Then we are going to lose all the data. Now, to address this, the natural solution is to replicate the database. Now, instead of saving everything in one database, everything is saved in two or more databases. Now, when writing a key value pair in the database, the backend will send it to all the databases. Even if some database crashes, it's still not a problem because several other databases are still alive. So now we have solved the single point of failure problem. But do you see any problem with this approach? As you might have guessed, the answer is yes, there's a problem. Suppose initially the key A stores the value 1 in all the databases. And now assume there's a new write operation for key A with a new value 3. Replica B updates the database and sends an acknowledgement to the backend. The backend will commit the operation. But now, suppose the database replica B fails. And it happens before replica B propagates the update of key A to other replicas A and C. Now assume another read request for key A is received and the backend will request the remaining databases to serve it. But the remaining databases don't have the up-to-date state, meaning they still have A set to 1. Hence, the backend will receive stale information. In distributed computing, this is called the consistency problem. Ideally, we want to make sure that at any given point of time, all databases should have the same state. Formally, we say strong consistency guarantees that every read operation returns the latest write operations result, regardless of the node on which the read operation was executed. This is the problem that's addressed by consensus protocols. Consensus protocol ensures that despite the failure of minority of the node failures, all the databases will be strongly consistent, meaning that all read requests will read the result of the last write operation that was applied to the replication protocol. For the rest of the discussion, we are going to omit the front end and the back end from our discussion, and we are only going to look at the interactions between different database, between the set of database nodes. Formally, a consensus protocol ensures that despite the failure of minority of the nodes, each replica of the database agrees on the same value. A correct consensus protocol should satisfy 4 properties, namely agreement, validity, termination, and integrity. Agreement property states that no two replicas agree on different values. Stated otherwise, each replica agrees on the same value. Validity property states that any value that's agreed upon is previously proposed by some replica. So informally, this means that consensus cannot invent new values out of thin air, but rather the decided upon value should be something that was proposed by a replica before. Termination property states that eventually each replica will decide some value, meaning we cannot have a state where a few or all the replicas just wait without deciding anything. That cannot happen. We want to make sure that eventually each replica is going to decide some value, and we refer that property as the termination property. And finally, integrity property mentions that no node decides twice, meaning once a replica decides on the outcome of the consensus, then that value should never change. Now, of course, at this point, these few properties will not be very clear, but they will become clearer when we study concrete consensus protocols in the next set of lectures. Now, it doesn't really make sense to agree on just one value, but rather it would make sense to agree on sequence of values. In distributed system terminology, we refer to this as a replicated log. So the idea is replicas run the consensus protocol for each replicated log instance and make sure that each instance of the replicated log has the same value across all the replicas. Now, it doesn't really make sense to just store the history of commands. I mean, why would anyone do that? Unless you use it for something useful. And this is where state machine replication comes to play. Now, in this context, we refer the state as the final state of the database once all the operations in the replicated log are applied. So if each replica has the same replicated log, then applying each operation to the state machine provides the same output state. And this is the foundation of strongly consistent distributed systems. Now, consensus is not at all a new topic. In fact, consensus has been researched for over more than 40 years now. And most importantly, they are deployed in distributed systems that we use daily without knowing that they actually use consensus. So that's all for this video. In this video, we first look at the traditional single database approach and the single point of failure problem. We then talked about the notion of consistency and why we need a consensus protocol to ensure strong consistency. Then I introduced how consensus helps to achieve strong consistency, followed by some discussion on state machine replication. I hope you enjoyed this video and see you in the next video.